Hello class, today we're going to learn about the max and min quadratic problems. So far we've been learning about the three different forms of a quadratic equation, and each form tells you a different part about the quadratic. So in standard form, this tells you your y-intercept, which is your c value. In factor form, it tells you your x-intercepts here. And in vertex form, it tells us the vertex, which is h and k. And so far we've been learning how to go from one form to the other. So to go from standard to factored form, we would factor. To go from standard form to vertex form, we would use the new method, completing the square. And then if we need to go back into standard form, we would use the same method, whether we're talking about vertex or factored form, which is to expand the brackets and distribute or multiply the terms out. And so in today, our problem that we're going to talk about is max and min problems, which means that we're looking for, in a quadratic graph, the max or the min values, which are the highest point if we're talking about the max, or the lowest point when we're talking about a minimum. And so we might be looking at the max or min, which essentially is just the vertex. So we're going to have to acquire the vertex somehow from the other different forms, which may mean completing the square. And so let's look at our first problem and see which way we're going to use. The first problem deals with a path of a ball modeled by the equation y equals negative x squared plus 2x plus 3, where the x value is the horizontal distance in meters from a fence, and the y value is the height in meters above the ground. And so the question is asking us for the maximum height of the ball. So we know that we're going to look for the vertex. And at what horizontal distance does it occur? So that's the maximum height of a ball, if you think about it, is the y value, which is talking about the height. So that means we're looking for the y value of the vertex. And then the horizontal distance it occurs, well, the horizontal distance is x. So that means we're looking for the x value of the vertex. Okay, so let's take our standard form equation, which was given to us, and complete the square in order to find the vertex. So if you look at the equation, the very first thing we must do is to factor out the a value, because we need it to be 1 in front of the x squared in order to complete the square. So once I factor out the negative 1, it becomes x squared minus 2x, because we're dividing these two terms by negative 1. We're not going to do that for the last value here, the last term. The positive 3 just trails behind because it's not involved in completing the square. And now that I have the a value equal to 1, I can use this b value and find out how much I need to complete the square, if you recall the diagram we've been using. Okay, so I take my negative 2 as my b, divide that by 2, which equals to negative 1, and then I square it, which means that I need to add and subtract 1 into the equation in order to create a perfect square. So I'm going to write out y equals negative 1 x squared minus 2x. Now I'm going to add the 1 and subtract the 1 because I don't want to change the equation. And then I just leave the positive 3 at the end. But by adding in that positive 1, that now creates a 3-term expression which creates a perfect square factoring, which when I factor these 3 terms, I get the format of x minus 1 squared. And so I still have in front, I have my y equals negative 1. And what's behind? Well, we have to think about the fact that this negative 1 is not used in completing the square. So that means that it has to be brought out of the bracket so that I can collect it with the positive 3. But in order to bring it out of the bracket, I must multiply by the a value. So therefore, negative 1 times negative 1 is a positive 1. I still have that positive 3, which I can collect with that. And so my equation becomes y equals negative 1 bracket x minus 1 squared plus 4. So there is my quadratic equation in vertex form. So as we mentioned, the question is asking us for the maximum height, which is our y value. So if our vertex. So our vertex in this question is 1, 4. So the maximum height, or the maximum value, is going to be our y value. And that what horizontal distance did it occur? Well, that's going to be our x value. So this is the horizontal distance that reached the max. Okay, and so I can write a therefore statement which explains all this. The next question asks me to sketch a graph. So I have at least one point, the vertex, which is sitting at +1 and 4, which can be somewhere here. And then I need another point in order to draw. And we actually have one without having to do much algebraic work. Is this here, the c value in a standard form, is our y-intercept. So I can include that in my graph, which is right here at 3. So I can now draw my quadratic graph, and I'm going to stop there. Why am I stopping there? Well, you have to remember that the y-axis is telling us the height of the ball above the ground. And so that could only be a positive y values, which is above here. And so I'm not going to put arrows and go into the ground. So I'm going to stop it right there. But the reason why I can do the negative x values is because the x is just telling us the horizontal distance, right, from the fence in meters. And that horizontal distance can be in front of the fence, so being the positive x realm, or it can be behind the fence, which is the negative x realm. So that's why that's allowed. Okay, so now we've finished our projectile ball. We're going to go to another example, and we're going to talk about a fence. Randy is building a fence at the side of a warehouse. So I'm going to draw a side of a warehouse, something like this. And he has 120 meters of fencing where he's going to create and plans to use the side of the warehouse as one side. So this side will not have a fence. Instead, he's going to create a rectangular fence. So we'll go out from the warehouse, across, and back to the warehouse. So all that's green is what's going to be used to build the fence. The question asks us for the dimensions of the maximum area that Randy can enclose. So we're talking about the area of a rectangle, which you recall the formula is length times width. So we can imagine this is our length, and this would be our width of our rectangle. They didn't give me the dimensions, so therefore we'll have to use a variable as a placeholder to calculate. So if you can imagine that if we let the width be x, if that side's x, then this side's also x. And I'm going to write my therefore statement stating that the x is going to represent the width of the fence. But I also need the length of the fence because I'm going to need that to input into my area formula. Well, if I only have 120 meters, I've used up an x amount and an x amount. So the length is what's remaining. So that would be 120 meters minus the 2 x's. So that's that dimension. So I can fill it into my area equation of area equals length, which is 120 minus 2x, times the width, which was x. And so this is factored form, and I'm going to distribute it out so that I can have a quadratic equation in standard form so that I can go back into vertex form. So 120 times x is 120x. Negative 2x times x is negative 2x squared. And I'm just going to rearrange this because I think it helps you see the quadratic equation better. So now I have a quadratic equation of area equals negative 2x squared plus 120x. And so as we mentioned, we're talking about trying to find the maximum area. So that means I need to find the vertex, which means completing the square. So the first step always is to factor out the a value from the expression. So I'm going to take that out, negative 2, which means I have an x squared minus 60x left over. And then to complete the square, I need to find the missing piece of my square, which is b over 2 squared. So this is my b value, negative 60, divided by 2 squared is negative 30 squared, which is 900. That means I'm going to add and subtract 900 into the equation. So area equals negative 2, bracket x squared minus 60x plus 900 and minus 900. And so to know that we did it right, we have to look at these three terms and see if that is a perfect square factoring, which it is, and it would produce the expression of x minus 30 bracket squared. The square of 900 is 30. And so I still have my area equals -2 in front. And now, don't forget that this minus 900 is inside the bracket, so I need to kick it out by multiplying it with the a value. So -2 times -900 would give me a positive 1800. And so therefore now I have my vertex form. So that means the vertex is going to be 30, 1800. So thinking back to the previous question, the y value is the maximum amount, which means if you look at the original equation and what the question asked us for, where the maximum amount is the maximum area. So the maximum area is 1800. But that's not what we're looking for. If you look at the question, it said, what are the dimensions of it? So I need the width and the length. Well, we said that the width is the x. Well, in the vertex, this is the x, and that is the width the width of the rectangle that would produce the maximum area. So that means I can now write that the width of the rectangle is x, which is 30 for a maximum amount, or 30 meters. But I also, dimensions are two-dimensional in a rectangle, I need to figure out what the length of this rectangle is. And remember that that was the formula of 120 minus 2x. So 120 minus 2 times 30, which is 120 minus 60. So now that means there are 60 meters in my length. So I can write therefore a statement describing that the dimensions of the maximum area you can use is 30 meters by 60 meters. And now we're just going to wrap this up with one last question, everyone's favorite, the revenue question. So Alex runs a snowboarding rental business that charges $12 per snowboard and averages 36 rentals per day. She discovers that for each 50-cent decrease in price, her business rents out 2 additional snowboards per day. At what price can Alex maximize her revenue? So we have to think back to the revenue and what that revenue equation is about. So when you think about revenue, you should think about that to get the money in, you're talking about the price you're selling your products at times the number of units you've sold. So normally Alex would have sold her snowboards for $12 and she would have rented out 36 of those snowboards. And that would be her normal revenue. But that's not what she's looking at now. She's thinking of changing it. And the way she's thinking of changing it is that she knows that if from the $12, if she decreases it by 50 cents each, so that's 0.5 each. So each is going to be X. That she's going to end up renting out, instead of 36, she'll be able to rent out 2 more for every increase. So for every decrease in price, she gets to increase the number of snowboards. So I'm going to write my let statement, where X represents the number of 50-cent price decrease. So I can go with 50, $1, $1.50. All right, so this is factored form, and you've actually learned how to solve this question in factor form, where if you recall, this produces, from factor form, you can find the 2 x-intercepts. And if you remember that a revenue goes into a opening down type of quadratic, if I know our 2 x-intercepts, we could find the axis of symmetry by adding them up and dividing by 2. That's our AOS. And then using that axis of symmetry as our x value of the vertex, you could figure out the y and figure out the maximum. So we can do that, or we can transform this into standard form and then complete the square into vertex form. Since we're in the unit of completing the square, that's what we're going to do. So here is the completing the square solution. The vertex ends up being 3, 531. Take a look and read through to make sure you understand the completing the square again, but I'm just going to interpret the answer. So the question says, at what price can Alex maximize her revenue? The $531 is the maximum revenue, but that's not what the question is asking for. It's for the price, which is the 12 minus 0.5x. So I actually need to calculate that using the x that was figured out with the vertex. So when you calculate it, it ends up being $10.50.